Hi friends, this is question number 1, exercise 4.4 pertaining to quadratic equations. This part 1. Find the nature of the roots of the following quadratic equation. Part 1 is 2x square minus 3x plus 5 is equal to 0. Now we have a formula for the quadratic equations, that is ax square plus bx plus c is equal to 0, and the formula is for the roots of the equation, so which is nothing but equal to minus b plus minus under root of b square minus 4ac divided by 2a. So this formula will tell us what are the roots of the quadratic equations. But the main important thing in this particular case, how we will come to know whether the roots are real and distinct and real or equal, how the roots are real and distinct, and how the roots are real and equal, or how the roots are not real, or they are just imaginary or cannot be computed. So how we will come to know? Just I'll explain. Let us first let us write the formula. The formula we know the roots of the quadratic equation ax square plus bx plus c is equal to 0, and its roots are as x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. Now the roots are nothing but these are the values of x, because this is a quadratic equation in the form of x square, where the degree of x is 2, so which means it will be having two values, because any square gives us two values in the form of plus minus. So in this case we are getting two values, that is minus b plus minus under root of b square minus 4ac by 2a. Here minus b oblique 2a, that is okay, that is a real number, but the main important determinant for the nature of roots is this particular portion, that is b square minus 4ac under root. So if the value of b square minus 4ac is 0, so this whole portion becomes 0, that is b square minus 4ac under root. So we are left with only minus b plus minus 0. It means both the roots are minus b by 2a. So both are equal. in this case when b square minus 4ac is 0. When b square minus 4ac is more than or greater than 0, then we will be getting under root of positive number which is also real, and real plus real number will give us overall real and distinct number. Why? Because real plus real and real minus real, this will give us two roots, two answers. So that's why it is real and distinct. Roots are real but their values are different. So there is no problem. So in such a situation, so in such a situation where b square minus 4ac is greater than 0, then the roots will be real and distinct. When b square minus 4ac is less than 0, that is, it is negative, then under root of negative cannot be computed. Then under root of negative number cannot be computed. So when it is cannot be computed, which is a portion of the whole formula, so we cannot compute the roots of x because this is not real number. So in such a situation we will say roots cannot be computed as these are not real. So three situations we have now. Three situations we will be having, so which will tell us the nature of roots. Now this is the formula for the quadratic equation ax square plus bx plus c is equal to 0, which is a standard form of the quadratic equation. In this particular case, that is part 1, we have been given 2x square minus 3x plus 5 is equal to 0. So we will compare both the equations. So what is a, b, c in the given equation, and we will put in the formula, or because in the formula what is the deciding factor is b square minus 4ac. So we will calculate first value of b square minus 4ac. We will see what is the nature of the roots. If it is real and distinct and equal, then we will go ahead, we can find out the value of the roots by using a complete formula. If it is not real, then there is no point going ahead with that. So first we will calculate the value of b square minus 4ac. If it is more than 0 or equal to 0, then we can find out the roots, otherwise we cannot find out. So accordingly we will proceed further. So now we will compare. In this case, what is, on comparing the given equation with the standard equation, we will be getting a is equal to 2 on comparing the given equation with the standard quadratic equation. We will be getting a is equal to 2, because this is ax square and in the given equation it is 2x square, so a is equal to 2, and bx is the standard form of equation. So bx here it is in the given equation it is minus 3x, so b is equal to minus 3. And plus c, that is constant, and constant in the given equation is plus 5. So c is equal to plus 5. So we will write c is equal to plus 5. Now we will calculate c is equal to plus 5. We will calculate, hence b square minus 4ac is equal to, b square is minus 3 square minus 4, a is 2, 4 into 2 into c is 5, which is equivalent to 3 minus 3 whole square is plus 9, because minus minus becomes plus here, and 5 into 4 into 2 8, 8 into 5 40, so this is minus 40, so 9 minus 40 is minus 31, so this is less than 0. So when it is less than 0, so under root of b square minus 4ac, that is negative, we cannot compute, so this is not a real root, so we cannot find the value of this one. So we will say, as b square minus 4ac is negative, there are no real roots. So we cannot compute it. So this is part 1. Now the part 2 of the same question is, it says 3x square minus 4 under root 3x plus 4 is equal to 0. Again we will repeat the same thing. As we know, the roots of the standard equation ax square plus bx plus c is equal to 0 are given as x is equal to minus b plus minus under root b square minus 4ac divided by 2a. Now, as I have mentioned in the part 1, so on the same lines we will proceed further in this case also. So on comparing the given equation, with the standard quadratic equation, we get a is equal to, this is ax square, and in the given equation it is 3x square. So a is equal to 3, b is equal to, that is minus 4 under root 3. So b is positive here, ax square plus bx, where it is minus, so minus 4 under root 3. So b is equal to minus 4 under root 3, and c is equal to 4 in the given equation. C is equal to 4. Now b square minus 4ac is equal to b is minus 4 under root 3 whole square minus 4 into a is 3 into 4, c is 4 here. So this will give us minus minus becomes plus 4 square is 16 and under root 3 square is 3. So 16 into 3, this becomes 48 minus 4 into 3, 12 into 4, 48. So 48 minus 48 is equal to 0. So b square minus 4ac is equal to 0. So the roots are real and equal, because once b square minus 4ac is 0, so minus b plus minus b square minus 4ac under root, that has also become 0. So only roots left are minus b by 2a. So the roots are real and equal. And how much it is? X is equal to minus b plus minus b square minus 4ac divided by 2a, which is equivalent to minus b is how much? B is minus 4 under root 3, so minus b becomes 4 under root 3 plus minus 0 divided by 2a. A is how much? 3. So 2 into 3, 6. That is 4 divided by 6 under root 3. That is 2 into 2, 4, 2 into 3, 6. This becomes 2 by 3, 2 under root 3 by 3. So these are the, both the roots are same here. So that is 2 under root 3 divided by 3. So this is over now. Now the part 3 of question number 1, exercise 4.4 pertaining to quadratic equations is 2x square minus 6x plus 3 is equal to 0. We have to find the roots of the equation and the nature of the roots, and if they exist, then we have to find the value of the roots, which means we have to find the value of x. So again, as we have repeated in question number 1 and 2, same thing we have to repeat here. We know the roots of the standard quadratic equation are given as by the formula x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. Now what is a, b, c in this particular case? We will compare the given equation with the standard quadratic equation, which is nothing but, you can say, ax square plus bx plus c is equal to 0. So on comparing, we will be getting a is equal to 2, b is equal to minus 6, c is equal to 3. So on comparing the given equation with the standard quadratic equation, we are going to get here a is equal to 2, as ax square is comparable with 2x square, so a is equal to 2, and bx is equal to, as per the given equation, it is minus 6x, so b is equal to minus 6, and c is equal to plus 3, so c is equal to plus 3. We will calculate the value of b square minus 4ac. Then we will see what is the value. Here b is minus 6, so b square becomes minus 6 square minus 4ac. 4a is 2, c is 3, so this becomes minus 6 square is 36, minus 6 square is 36, minus 4ac, 4 into 2, 8 into 3, 24. So minus 24, this gives us 12. So it means that the value of b square minus 4ac is positive, more than 0. The roots are real and distinct. So what are the roots now? X is equal to minus b plus minus b square minus 4ac divided by 2a, which means minus b is how much? So minus 6. So minus minus becomes, it's a minus 6 plus minus under root of b square minus 4ac, we have got it to 12. So under root of 12 divided by 2 into a is 2. So this has become equivalent to minus and minus 6, that becomes plus 6 plus minus, so 12 we can write 2 into 2 into 3, and 2 into 2, that gives us under root of that becomes 2 into 3, 2 into 2 into 3, so 3 will be remaining as under root 3, and 2 into 2 will give us 2 real number divided by 2 into 2, 4, which is equivalent to so here it will give us, if we take 2 common, so we will be getting minus under root 3 divided by 4 or 2 2 4. So this will give us two roots. One is 3 plus under root 3 by 2, and second is 3 minus under root 3 by 2. So now the roots are real and distinct, and these are 3 plus under root 3 divided by 2, and second one is 3 minus under root 3 by 2. So these are the two roots of the given equation. This is over now.